Hello everyone, let's solve the second question from today's weekly contest, that is count submatrices with top left element and sum less than k. So you're given this matrix called grid and an integer k. So all you have to do is return the number of submatrices that contain the top left element of the grid and have a sum less than or equal to k, right? Alright, so let's understand. So what you're being told is you're told that starting from this, right, this top left corner, you have to consider all the submatrices that starts with this top left corner, and you have to calculate their sum. And by taking this sum, you have to simply check if that particular sum is less than equal to k. If it is, then include it in your count, right? So you have to count all those submatrices whose sum is less than equal to k. So let's consider this particular, right? So let's calculate all the sums. So if I consider this particular starting from 0 comma 0 ending at 0 comma 0, right? So see, here your top left corner is fixed. You have to consider only those submatrices that have this top left corner, and bottom right can vary. This can be your bottom right, bottom right, bottom right, bottom right, etc. So you have to calculate their sum. Okay, so now let's create the sum array, and here it's 7. You're going to have 7, then 7 plus 2 up to this. If you consider bottom right, it's going to be 9. And if you consider this part, right, 7 plus 2 plus 9, it will be, what is that? 18, correct? Then if I consider this as the bottom right, then this will be your submatrix, that is 7 plus 1 8. If I consider this as bottom right, then this will be your submatrix, that is 7 plus 1 plus 2, that is nothing but 10. Then if I consider this as the bottom right, so then this will be my matrix. So if this is my matrix, what is the sum? 7 plus 2 plus 1 plus 5, which is nothing but 15. Then if I consider up to this point, right, so this will be my submatrix. So if this is my submatrix, what will be the sum? Up to here it was 18, 18 plus 1, 19 plus 5, which is nothing but 24. 24 plus 0, right? So 24. Then if I consider up to this point, what will be the sum for this submatrix, right? So for this submatrix, the sum is going to be, this is already 10, 10 plus 11, 21 plus 2, 23, correct? So it will be 23, 23. Then up to here, this whole matrix will be considered, correct? So the sum up to here would be, up to here we know it's 24, 24 plus 2, 26 plus, it is 26 plus 6. What is it? Up to here we know, right, it's 24, right? 24 plus 8 plus 6, which is nothing but 14, which is 38, right? So I know the sum. All right, now I have to check all these sums, right? All these sums that we have calculated here, I have to check for all those values whose sum is less than or equal to k. So k is here what? K is here 20, right? If k is 20, I have to check all sums that are less than equal to 20, correct? So 7, 9, 18, 8, 15, 10. So these sums are less than 20, and how many are these sum matrices? These are 6, correct? So you will return 6, right? So here in this case also you'll see what you have to return, 6. Now, I hope now it's clear, right? What you have to do in this question. Consider all the submatrices which have the top left corner as this, right? Or 0 comma 0 cell, and bottom right can vary. Now, if you try to, simply write a brute approach for this question, you will get TLE. The reason being, you will first start from I is equal to 0 to n. Then you will start from for j is equal to 0 to n or m, right? And then you will start calculating for the sum, right? You have to calculate, so you will declare this sum variable, and x will be starting from I to n. And for so this will be 0, okay? And all right, it's starting from I, and this will be starting from, and for let's say y to y starting from j to n, and then you'll simply check if top left is 0 comma 0, and for only those matrices you calculate the sum. So overall time complexity you'll see will be big of n raised power 4, right? So if you see the constraints, right, if you see the constraints, n and m can be up to 1000. If n and m can be up to 1000, this will become big O of n is can be up to 1000, correct? So big O of 10 is for 12, which is huge, right? And it will give you TLE. So obviously we cannot use this approach, right? We cannot write brute force here. Then what can we do, right? How can we optimize it? See, we can optimize it using a technique called prefix sum, right? So this is a pre-computation technique. So in this technique, what happens is, let's say you're given a matrix, okay? Let's say you're given a matrix and you have a cell, let's say A comma B, and you have a cell, let's say C comma D. So you are given these cells and this prefix sum matrix you have already formed. You can return the sum of this sub matrix in O of 1 using this prefix sum matrix, right? So this is what we are going to use. So to make prefix sum, big O of n square is utilized, and after utilizing big O of n square, simply you have to iterate inside of this prefix sum and you will be able to calculate the sum. Now how we can use prefix sum? You can already see here that in the brute force approach, what we are doing is we are doing something twice. Let's say I want to calculate sum up to this, right? So I will have to calculate 7 plus 2 plus 9, right? Then I will get 18. But if you already see that 7 plus 2 I've already computed up to this cell, correct? Which was 9. So if I simply take this 9 and simply add this particular 9, the value, I will get 18, right? So I am doing this repeatedly. Similarly for all the matrix. Let's say I want to calculate the sum up to this, right? For this matrix. If I want to calculate the sum, if I know the sum up to this point, right? And I also know the sum up to this point because I would have already calculated it. If I know the sum up to this point and this point, and if I simply remove this sum, because see, for this matrix, let me take another pen. This is the sum, correct? And for this one matrix, the sum is this part. This is your sum. So you are adding this particular sum twice, right? So if you remove this sum once and then add this element, you will get your sum, correct? So this is the reason we can calculate or pre-compute these submatrices value, okay? So now all you have to do is simply, let me write it here also. You have to compute s of I comma j as s of, you will know the sum up to I minus 1 and j itself, and you would also know the sum up to j minus 1 itself, right? And because this is already including I minus 1 and j minus 1, right, twice, so you have to subtract that. You have to subtract that and you will get this, correct? And also add the current array value, which is array of I comma j. Okay, so let me quickly do a dry run for you and let's create this matrix. Okay, let's take the original matrix, which is 7 2 9 1 5 0 and 2 6 6, right? This is the grid value that is given to you. Now we'll start making this prefix array, right? That is s. So first what you have to do is for rows and columns, you can already see that if you keep adding the values, right, you will get it, correct, for a particular row. So these we will compute before calculating for whole the matrix, correct? So first we'll calculate for 7, then 7 plus 2 it will be 9, then 9 plus 9 it is going to be 18. Similarly here 7 plus 1 8 and 8 plus 2 10. So after computing this, you will start iterating from I is equal to 1 as well as j is equal to 1. Now, let's come to this cell. So I'm saying what? Go to I minus 1th cell. I minus 1th cell is what? It is this, correct? I minus 1 comma j cell. So add 9 plus add 8. Then subtract I minus 1 and j minus, which is 7. Subtract 7 plus add current element, that is 5. So if you see, this is 2 plus 8 plus 5, which is nothing but 15. So it will become 15. Now if you want to calculate up to this point, take this sum and this sum, which is 18 plus 15, subtract this sum, that is 9, add the current array element, which is 0. What you will get from here, you will get this will become 6 plus 18, which is nothing but 24, correct? Now if I want to calculate the sum for here, take 15, take this value 10, add them, and also subtract this 8, right? That is I minus 1th and j minus 1th cell. You calculate this and also add this particular value, which is nothing but 6. What you will get? 10 plus 15 plus 6. uh okay, wait, let me write it clearly. So you will add 15, you will add 10, and then you will subtract 8, correct, and add 6. So what you will get? From here you will get 35. So 10 minus 8, it is 2. So basically 15 plus 8, which is nothing but 23, correct? Then you have to calculate up to this point. Take 23 plus 20, oh, sorry, 24 plus 23, subtract 15 and add current cell value, which is nothing but 6. What you will get? So you are subtracting, so this will be 8, correct? So 14 plus 24 it will be, which is nothing but 38. Now look, this was the matrix, and you are now getting 7, 9, 18 again, 8, 15, 24, 10, 23, 38, right? So this is how you create the prefix sum. After you have created prefix sum matrix, you know that I want to check for all submatrices that start from 0 comma 0. So you already know the way you calculate prefix sum is that you are taking this, right? If I say this cell, right, this is the sum of which submatrix? This submatrix. Okay, if I say this is the sum of which submatrix? This submatrix, right? So if you simply iterate in prefix sum array and simply check for these values less than equal to k, you will still get your answer, because it is already like that, right? It is created as 0 comma 0. It is computed as a comma b is 0 comma 0 for each and every cell, and up to I comma j. For these submatrices you have stored the sum. Each cell represents this sum, correct? So that you can know in O of 1. All right, so this is the basic technique that we had to use. Let me show you the code quickly. See, here I have created this prefix sum function. Now here I am calculating the prefix sum. This I have only resized it because I just passed it like this here. So you have to initialize R and C for here, then check for this, right? Oh, sorry, PS 0 comma 0 is going to be a 0 comma 0. Then form the sum for each and every column, as well as form the sum for each and every row. After you're done with that, iterate here, and what I wrote there, you have to simply write it here, correct? That is, take I minus 1th and jth cell, I j minus 1th cell, you have to add them and subtract I minus 1th and j minus 1th sum and add the current array element. So this way you will be able to get your sum up to I comma j for this particular matrix, right? So the bottom right corner is this and top left will be 0 comma 0. After creating this prefix sum, right, I'm storing these values in PS. These elements simply represent the sum up to what? 0 comma 0 to I comma j, right? So I'm simply checking for each and every element, right? Because that's what's mentioned in the question. The top left element of the grid you have to consider, right? Bottom right can vary. So bottom right is varying, and you are checking all these submatrices, and if the sum is less than equal to k, do ans plus plus and return ans. So this is basically how you have to solve this question. If we see the time and space complexity for this, time complexity will be simply big O of n square because it is a matrix, and space is also big O of n square for prefix sum matrix, right? So I hope now you have understood the question, and that is it. That is how you have to solve it.